Hi, our topic for now is reactions in solutions. Most of the reactions in the lab are carried out in solutions. Solutions are made up of solute and solvent. So these two components put together make a solution. So we need to understand how the amount of substance can be expressed if you are dissolving that substance in a solvent. So this substance is nothing but our solute. And solutions can be concentrated or dilute. That means the concentration of the solution completely depends on how much solute is dissolved in how much solvent. So all this has to be expressed. And we can express this either by using mass percentage or mole fraction or molarity or molality. So these are the four different ways which are used to express the concentration of the solution or amount of substance present in the solvent. We will study each one starting with mass percent, also called as weight percent. Now if you look at this, you should know in what terms are we expressing the solute and the solution. So when you look at this, you know on the numerator you have the weight and the denominator is also the weight. So you have mass of solute by mass of solution into 100. So this is solution, which means it has both solute and solvent. So this has to be remembered because during numericals, if the mass of solvent is given, students tend to write that directly in the denominator, ignoring the solute part. So denominator is not mass of solvent, it is mass of solution that has to be remembered. Now let us solve a numerical. A solution is prepared by adding 2 grams of substance A to 18 grams of water. Calculate the mass percentage of the solute. So your substance A is your solute and water is your solvent. So that's our formula to find out mass percentage. Let us substitute. Mass of A is given as 2 grams and mass of solution is not given in the question, and we know solute plus solvent becomes solution, so our denominator will be 2 plus 18. So we have 2 by 20 into 100 because it's percentage, and the mass percentage of the solution will be of the solvent will be mass percentage of the solute is 10%. Next one, mole fraction. It is the ratio of number of moles of a particular component to the total number of moles of the solution. Now this is very convenient to find out the mole fraction of a substance, irrespective of how many particles you have in a solution. Now if we are considering a solution which has only two substances A and B, then the moles can be expressed as Na and Nb, and mole fraction can be calculated like this. So number of moles of A by total number of moles of the solution. Now, in this case, we have only two substances A and B. So mole fraction of A can be written as moles of A, that is Na, divided by total number of moles in the solution, that is number of moles of A plus number of moles of B. Okay. So what is the mole fraction of A? That we can get simply by dividing moles of A by total number of moles in the solution. Similarly, for mole fraction of B, we need to divide the total number of moles of B by total number of moles of the solution. So that can be written as NB divided by Na plus Nb. So number of moles of B divided by total number of moles of the solution. Now in case you have more substances, if I have say a third substance C, then in the denominator you will have number of moles of A plus number of moles of B plus number of moles of C. And of course the numerator will be whatever you're calculating. If you're calculating mole fraction of C, it will be number of moles of C. Okay, so the denominator depends on how many substances are there in the solution. Okay. A solution is prepared by dissolving 1 mole of ethanol in 3 moles of water. Calculate the mole fraction of ethanol and water. So we have only two substances here, ethanol and water. So let us assume that number of moles of ethanol is Na and number of moles of water is Nb. Now you can either write this statement and write this formula to calculate for ethanol and then to calculate for water, or you can write the entire formula. It's your choice. If you're writing these kind of formulas, then you need to mention what is Na and what is Nb. Otherwise you can directly write these formulas and you can substitute. So mole fraction of ethanol will be number of moles of Na by total number of moles, that is 1 plus 3. So it is 1 by 4. You need to further simplify and write 0.25. And the mole fraction of water will be, it says 3 moles of water. So 3 divided by 1 plus 3, that is 3 by 4. Further simplification gives us 0.75. You need to note here that mole fraction does not have any units. The next way of expressing the concentration of the solution is molarity. Molarity is the number of moles of the solute in 1 liter of the solution. Molarity is always represented by writing capital M. So we have number of moles in the numerator and volume in the denominator. Say for example, if we have 1 molar solution of NaOH, it means that we have 1 mole of NaOH in 1 liter of the solution. If we say we have 5 molar solution of HCl, that means we have 5 moles of HCl in 1 liter solution. So it is always for 1 liter and the number indicates how many moles of that substance are there in 1 liter. How much volume of 1 molar NaOH solution will be required to prepare 1000 ml of 0.2 molar of NaOH solution? Now, if the question says how many moles of NaOH is required to make 0.2 molar solution, then the answer is very simple. We will need 0.2 moles of NaOH to prepare 0.2 molar solution. But the question here is slightly different. We are starting with 1 molar NaOH solution. We have 1 molar NaOH solution. Using that, we need to prepare 0.2 molar solution. 1 liter of 0.2 molar solution. So how much of 1 molar NaOH solution we need to take so that we can dilute it and we can have 1 liter of or 1000 ml of 0.2 molar NaOH. So when you have such numericals, you can calculate by using this expression, that is m1 into v1 is equal to m2 into v2, where m and v are molarity and volume. Now let us assume, or let's take m1 to be 0.2 molar and v1 to be 1000 ml. That's the solution which we want to prepare. And the solution what we have is 1 molar NaOH, and that we will take it as m2. So how much of this solution we require? That's volume 2 that we need to find out. So simple cross multiplication, v2 is equal to 0.2 into 1000, and that will be 200 ml. Okay, so you need to take 200 ml of 1 molar NaOH solution and dilute it so that it becomes 1000 ml. That means you are ending up with 0.2 molar NaOH solution. Now in the previous example, what we saw was we had 1 molar NaOH. Now using this concentrated solution, we are preparing a dilute solution. This is how it is done in the lab. Because when you are making a dilute solution, the mass of the solute required may be very, very small, and to weigh that small quantity you may have issues, or the quantity required may be so small that you will not be able to accurately take the exact amount. So we always take a concentrated solution and then dilute it. This concentrated solution is called as stock solution. Okay, so the problem is when you're preparing a dilute solution directly, then the mass of solute required is very, very small. So in order to get that exact mass, it's not possible. So they may be, the accuracy will not be there. That's why we take a higher concentration solution and dilute it. So that higher concentration solution is called as stock solution. The fourth way of expressing the concentration is molality. Molality is represented by small m. So you need to be very careful when you're writing molality and molarity. If your small m and capital M does not have any difference, then you better write the entire word molar and molal. Okay, molality is the number of moles of solute in 1 kg of solvent. So you have moles on the numerator. In the denominator, you have mass in kgs. The other one, the molarity, was number of moles by volume in liters. This is mass in kg. Slight difference. Okay, this is an interesting numerical. The density of 3 molar solution of NaCl is 1.25 grams per milliliter. Calculate the molality of the solution. So when we say 3 molar, that means we have 3 moles of NaCl in 1 liter. Okay, this we studied just now. Whenever you say molar, that means so many moles in 1 liter. So we know the numerator. Numerator is 3 moles of solute, that is NaCl. But we don't know the solvent, the mass of the solvent in kg. So we take the density that's given. We know density is equal to mass by volume. Density is mass by volume. So using this, we can find out the volume of the, we can find out the mass of the solution. So mass of the solution will be 1000 into 1.25, that's the density, and that comes to 1250 grams. So we know the mass of the solution, but that's not what we require. We require mass of solvent. So this solution has solute and solvent. So if we want only solvent, so from this we need to remove the mass of solute. Our solute is NaCl. 1 mole of NaCl has a mass of 23 plus 35.5. That comes to 58.5. So 58.5 grams is 1 mole. And here we have 3 moles. So 3 moles of NaCl will be 3 into 58.5. That is 175.5. So we know solution minus solvent, solution minus solute will give us the solvent. That is 1074.5 grams. But we don't want grams, we want it in kilograms. So that will be numerator, number of moles of solute is 3 divided by, this was in grams, we are converting it to kg, so it is 1.0745 kg. So molality of the solution is 2.79. One thing to note here, molality does not change with temperature.